Welcome students. This is the continuation of the previous video regarding the electrical potential. See, in the last video I have defined. You see how we can define the electrical potential at a point. The electrical potential at a point is defined as the work done in moving a unit positive charge or a test charge from the infinity to the point P against the electric force or electric force of repulsion or Coulombic force of repulsion inside the electrical field E. Till this you will be having the last video. There is a small continuation. Mathematically, that expression for potential can be defined as or written as potential at a point. Here the point is P. So Vp is equal to minus of actually E vector dot dr vector. It has to be integrated. When it is integrated, we have to move the charge from the point infinity to the point P. Since it is against the repulsion, I have given the minus and it is measured in terms of an unit called to be volt. See, from this we have to define some of the definitions, very important definitions in this video. The first definition that we have already studied there is taken to be what? The first video or the first definition that we have studied is potential energy difference. Okay, potential energy difference. How you can able to define this potential energy difference? Potential energy difference means it is the work done in moving a charge. Here we won't mark it out as a unit positive charge. The work done in moving a charge from one point to another, against electrostatic force or Coulombic force, against electrostatic force of, here it is, we have studied as repulsion. Electrostatic force of repulsion. We can consider like this. This potential difference represented as delta of epsilon, which is equal to epsilon potential energy at the point P minus potential energy at the point R, or you can say it out as integral of, because work done, integral of external force, that is minus of E into Q dash multiplied it with the distance dr. Here the multiplication is dot product. So work done as, we are saying it as F dot S. So E into Q dash dot dr vector, and it is moved from R to P. The potential energy is nothing but work done or energy, so measured in terms of an unit joule. Like this, from this potential energy difference, we can define potential difference. What is meant by potential difference? Potential difference is represented as delta V, measured in terms of an SI unit called to be volt, marked in terms of V. What is potential difference? It is nothing but potential energy per unit charge. So we can define in two ways. One, we can state it out as potential difference is defined as potential energy difference per unit charge, So how you can state this? Delta V is equal to potential energy is, change in potential energy is delta of epsilon divided by, take this q dash to the denominator, delta epsilon divided by q dash, which is equal to integral of minus of E vector dot dr vector, and this is integration from the point R to the point P, which is equal to potential at a point P minus potential at a point R. This is also considered to be potential difference. Definition for potential difference. Then the next one, we are going to get the definition for the potential at a point. What do you mean by the potential at a point? See, potential at a point is represented as V. If the point is P, then this V can be written as Vp. This Vp or V is also measured in terms of an SI unit volt, represented by the symbol V. So how to define or how to get the answer for this definition? So potential at a point, it is the work done in moving, work done in moving a test charge. Here it is a test charge, from infinity to a point where inside the electrical field, to a point inside the electric field. That electric field is E vector. Electric field against the force of repulsion or against the electrostatic force, or that force may be considered as what? That force may be considered as repulsion. These three definitions are very, very, very important. Moreover, we can also define the potential difference in terms of work done. See, or we can state potential difference also defined as the work done in moving an unit positive charge, from one point to another, against electrostatic force of repulsion. Against what? Against electrostatic force or electric field, whatever may be, electrostatic force. Here in our case, electrostatic force is repulsion. This is another definition. Either you can write this or you can go for this definition. Both are considered to be what? Both are considered to be correct. One in terms of potential energy and another one in terms of what? Another one in terms of potential work done. Here I have written it in terms of potential energy per unit charge. In this second case, I have written it in terms of work done. So all the definitions are correct. Each and every definition carries 2 marks. As a whole, you hope you might have understood this. As a whole, it may be asked for a 3-mark question. Okay, there are some important points regarding this potential energy, etc. So what are the important factors or the important points regarding this? So let us consider important factors or important points regarding this potential or potential energy or potential difference. Let us consider point number 1. First of all, I am going to talk about the potential V. So let us consider the potential at a point. See, potential at a point is given by either as V or as Vp. On what factor this potential depends on, and it is not depending on what factor. This potential depends on the source charge or the parental charge, and it is independent of the test charge which is moved. So I can say this potential V depends only on the parental charge or depends only on the source charge. What is that source charge? The charge which is responsible for producing the electrical field, that is plus Q. Similarly, this potential at this point is independent of independent of the charge or independent of the unit positive charge or the test charge that you have moved from one point to another point. So here we have considered this test charge as Q dash. So let us consider like this. The potential depends only on the source charge plus Q, and it is independent of what? And it is independent of the charge Q dash. See, if the test charge is moved from infinity to the point P, then we have to use an external agency. That external agency should not give any kinetic energy to the test charge. Okay, see, we have to move in order to find out the potential V. What I have calculated, I am taking the point R at infinity. From infinity, the point is moved inside the electrical field to the point P. Here you will be having what? Somewhere here you will be having the charge plus Q. So when I am taking this test charge Q dash from infinity to this point P, I am using an external force, because then only this charge can move. That external force should be used to move this Q dash with a constant velocity, because it should not impart any kinetic energy to the test charge. That we should note. So let us consider a note here. What does that note means? See, when you are bringing the test charge from infinity to the point P, from infinity to the point P, it should be moved with a constant velocity, That is, it should not get accelerated. So it should move with a constant velocity. Why? Because the external force that you are applying should not give, that's all, should not give, or I can say it should not impart kinetic energy. It should not give or it should not impart any kinetic energy. That is, the charge should not get accelerated. Any kinetic energy to the test charge Q dash. It should be you should have this in your mind. Then let us go for point number 2, the important point, the point number 2. What is the unit for electric potential? While writing that, I have represented the unit for potential or potential difference as volt. Is there any other method or any other value? Let us see. See, unit of electric potential. What is the unit of electric potential? Let us take like this, is equal to, what is that for electric potential? It is represented as V, defined as change in potential energy per unit what? Per unit test charge or per unit charge. So we can say that change in potential energy measured in joule divided by, what is the charge? Charge measured in coulomb. So joule per coulomb is considered to be the unit for electric potential or electric potential difference as V, or I can state it out as delta V. But this joule per coulomb, I can state by deriving this, but the practical unit of potential or potential differences, potential or potential difference is volt and represented in terms of an unit V. See, we can also state this unit potential difference. This is not in your book, but this will be useful for your entrance examinations. What do you mean by unit potential difference? Unit potential difference means 1 volt of, 1 volt of potential difference. Can you define this? Can you able to define this? What do you mean by this unit potential difference? See, 1 volt of potential difference or unit potential difference is, we can define like this, is defined as, if 1 joule of work is done, if 1 joule of work is done in moving unit positive charge, or test charge from one point to another against electric force of repulsion or against electrostatic force of repulsion or repulsion, against electrostatic force of repulsion, clear? This is not in your book, but you can say, what do you mean by 1 volt of potential difference or unit potential difference? 1 volt or unit potential difference is defined as, if 1 joule of work is said to be done when in moving and unit positive charge from one point to another against the electric force of repulsion. To the 3 definitions, you can add this as the 4th definition. This will be useful for you. Hope you should have a clear idea regarding electric potential energy, then electric potential energy difference, then what do you mean by potential difference, what do you mean by potential at a point, and also you have calculated or considered some important points and the unit for potential and potential difference. While studying, go through the previous video and this video continuously so that you can able to get a clear cut idea. Okay, so those who haven't subscribed, you please subscribe. Then only you can able to get the notifications whenever I am uploading a video. Thank you for watching this and hope this will be very useful for you. Thank you. Let us meet in the next video. All the best.